Make sure to like and subscribe right now. Yes, do it.
Hello everyone, this is Rick from MathX, and today I'll be doing a different style video than we normally do on this channel. If you may recall, a couple of months ago, we made this video, how to make AIME, or American Invitational Mathematics Examination, and that video actually got quite a bit of attention and a good amount of views, so, we're kind of just copying the trend and just making this video because I think it'll be more popular than what we usually upload. So today I will be talking about how I made USAPHO, United States Physics Olympiad. So this video really just have 3 parts. First, I'm going to discuss my journey throughout USAPHO and the competition process. Next, I'll go over the competition, its rules, and just other information regarding the competition. And finally, I'll give you some ideas on how you can study and prepare for this competition so that you yourself can make it to the highest levels. So without further ado, I'd just like to get started with the first phase, discussing my personal interest in physics and how I have learned from the Physics Olympiad track in the United States. So I started really getting interested in competition physics back in 9th grade. And this was really this interest was initially sparked through my school's science team, which I was terrible at, but it got me thinking a little bit about a lot of sciences. I'd been doing competitive math for many years before that, but that science team got me interested in the concept of competitive science competitions. So I did some research, and I found F is equal to ma, the introductory competition for the Physics Olympiad series. And that was the first year I took F is equal to ma, and I did really lame prep. I watched a couple of Khan Academy videos, and I figured, okay, I should be able to do something, right? But that was not at all true. I did the test, got 5 out of 25, so I did quite poorly. But it was my first introduction, and the following year I started prepping a lot more rigorously for it. So between the 9th to 10th grade, I studied a lot more rigorously. But keep in mind, as a 9th, 10th grader, my math was not up there to study actual rigorous physics. I didn't know calculus. I knew pre-calc, but as I'll go over later in this video, if you want to get really good at physics, you gotta go down the pure calc path. But I still kept on prepping, and I did do decent work. I managed to go from 0 physics knowledge to enough physics to cover an AP Physics 1 curriculum, and this was all through self-studying. So I managed to grow a significant level, but AP Physics 1 is far beneath the standard for F is equal to ma. So even though I improved on the competition, I only got 10 out of 25, which is far from the minimum qualifying score for United States Physics Olympiad. So, the following year, I just tried again, even harder. And this year, as a junior, that was kind of when I took the exam. And when prepping for this last year's exam, I took it a lot more seriously. Since I'd started, at the end of 10th grade with the AP Physics 1 level, I was trying to boost that and go beyond. And it was a combination of multiple factors, but I was able to qualify for the United States Physics Olympiad this year. The first factor was, as a junior, we were learning physics in school. So along with studying on my own, learning in school helped reinforce concepts, and I was able to pick on the more challenging problems. So this is the first factor. Second factor is during the summer I self-studied calculus, and I learned the basics of calculus to a calculus BC level, an AP calculus BC level. So this allowed me to have the mathematical tools to attack physics from a more advanced perspective. And these 2 factors combined, just the pre-physics knowledge and BC calc, along with a lot of my own self-studying, reading from books like Resnick Crane. I did problems from Iridov and Morin. Just doing this regiment was able to not only get me to clear F is equal to ma and qualify for USAPHO, but I managed to do it with a pretty good margin as well. The qualifying score this year I think was between 15 and 16, But on the F is equal to MA, I qualified with the 21, which just shows that I was like well qualified for the test. And even when I took the USAPHO, like I was not just sitting there like dumbfounded as I would have made like if I qualified the previous year. Since I studied a bit more rigorously this year, I was able to actually do pretty okay on the test and managed to earn a bronze medal for my efforts. So I overshot it there a little bit, and I'm pretty sure that if I have another year as a senior, I could probably go for a gold medal or something as such. But pretty much most of my growth happened between the 10th and 11th grade summer, as this was when I went from an AP Physics 1 level to a USAPHO level competitor. And I also took the AP Physics C exams, in both of which I got a 5 pretty easily without even studying for. Um, so that's pretty much my journey throughout Physics Olympiad. Um, Unlike math, one thing I would note is that physics is a lot more forgiving. You can make it to the really top even if you start Physics Olympiad really late, if you take the subject very seriously. So I remember reading online of examples of people who really start competitive physics in ninth grade and then make the national team in like 11th grade. So it's a really short window. I mean, just like everything else, you have to be dedicated. But unlike math, where you have to like in order to make it to the highest levels of like MOP or national team, you have to be doing math like nonstop since like third grade. Physics is not that way. Since physics itself is a more advanced topic, you can start at a much older age and still achieve similar levels of success. It's not easy, but I will say it's less competitive than the math track. Um, so hopefully that gives you good insight into my experience with competition physics and just overall competition physics in general. Um, I mean, I can't really say competition physics in general because this video I'll just be talking about F is equal to MA and USAPHO show, and I am aware that there are a bunch of other competitions, but I really have just been doing these two. So hopefully, don't take my word too generally. Just in this context of F is equal to MA and United States Physics Olympiad. Um, so now that I talked about this point, now to give you a an outline of the United States Physics Olympiad, just a Physics Olympiad track in the U.S. Okay, so everybody who wants to start with the Physics Olympiad track must start with the F is equal to MA exam. And about 6,000 students participate in this exam, and you can think of it kind of like the AMC 10 equivalent for physics. So, what does this mean? It has 25 questions for you to take in 75 minutes. There are two versions of the test, the A and B exam. And unlike the following exam, which tests on a lot of concepts, this physics exam is only limited to mechanics. So, literally just 25 questions of mechanics. I mean, there are slight topics. Like, they do, like, bring up, like, some stuff which is just not pure mechanics as you'd see on, like, AP physics. Like, there are some stuff like air, waves, sound. But for the most part, it's just mechanics. And uh, another thing, unlike the AMC 10 exam, where if you do the AMC 10, you would want to do both exams, the 10A and 10B, so you can maximize your opportunities for getting a high score and qualifying for AIME, because AMC 10 takes your super score. F is equal to MA doesn't really work like that. They don't really take your super score. If you want to take both exams, you can, but if you want to make USAPHO with both of them, you're going to have to qualify above the threshold for both of them. So that means it could be held against you that you don't qualify for United States Physics Olympiad because one of your scores is above the cutoff but another is below. So unlike AMC 10 where it's a good idea to take both tests, with that physical MA, just study and just take one. So that's F is equal to MA, okay? So let's say you take the F is equal to MA exam. You do really well, get above the cutoff between like 15 to 18. And then you qualify for the United States Physics Olympiad. The United States Physics Olympiad is a whole different monster. So let's say you take the F is equal to MA in February. United States Physics Olympiad is about a month later. And unlike the F is equal to MA, which only tests you on mechanics, on United States Physics Olympiad, anything goes. So not only mechanics, you'll also have to worry about E&M, fluids, relativity, atomic and nuclear physics. So pretty much just anything in physics is fair game. That being said, it's not as bad as it seems, because from what I've seen with the past year and all the other past years, um, most of the questions are just mechanics and E&M. Um, so, for example, the United States Physics Olympiad has two sessions, each 90-minute long, and each containing three problems. From what I've done with my research, um, typically four of those problems are either mechanics or E&M, with the other two varying between a selection of other topics. So let's say you're in a boat like I was back as a junior, where you'd been studying mechanics, got pretty good at mechanics, qualified through the physical to MA. But when you're in USAPHO, it's your first time taking the test, and you don't know anything else, right? What subjects should you study to maximize your score? The answer is study E&M, because thermodynamics, nuclear relativity, these have a maximum of current. Like these will maximum come up like on one out of the six questions, but you know for a fact that there's going to be a bunch of E&M and mechanics questions. So if you ever find yourself qualifying for United States Physics Olympiad where you've been stuck and you've just been studying mechanics this entire time, study E&M as well. It's a good way to boost yourself up, and I would honestly say just because I studied E&M is probably the only reason why I got my bronze medal. Otherwise, I would have got nothing on the exam. I would just sat there blank. So that's the United States Physics Olympiad. After that, you make their special camp and you go to University of Maryland, where they teach you theoretical and have their own testing process to choose your team, and that's pretty much it. So that's pretty much the physics track. And as I said before, unlike in math, right, it's actually much quicker to progress up the ladder. I made Olympiad like within like 2 years of trying, and I myself am kind of slow. I know people who've gone from zero to like the international team like that. So if you're very interested in the subject, I would highly recommend this as a potential competition to pursue. So now for the study path. As I said in the F is equal to MA section, F is equal to MA advertises itself as a test where it's just algebra based mechanics, so you don't actually need calculus. However, that's like more of a lie than it seems. I would still highly recommend calculus, but if you don't want to take on calculus too early, then it is still possible. But that being said, you have to make sure your algebra is very strong. Before even going into physics, make sure you can do trigonometry and all the algebra 2 concepts like really solidly, like factoring equations, no issue, trigonometry, no issue. And then you should probably look into like an AP Physics 1 level curriculum. So either get like an AP book or like get a class or follow the online videos. But first make sure your math is at an algebra 2 and trigonometry level. And then just find some way to learn the AP Physics 1 concepts and find some way to practice those concepts. And then once you do that, or you just go straight to calculus, once you do that, then you should focus on learning calculus, or as I said, you could just go straight to learning calculus. You don't need too much calculus to get into it. I would just recommend like knowing AP Calc at least an AB level. BC is recommended, but AB works just as fine. So I would recommend to learn the calculus reading from Paul's online notes. It gives you a good amount of context, and I'll give you a bunch of practice problems. So if you can do the problems on Paul's online notes like Calculus 1 and Calculus 2 pretty well, you have all you need for starting physics. Then, since you started with the physics approach, if you haven't already learned the basic physics concepts from Physics 1, or even if you have, I would still go through the AP Physics C curriculum because it'll give you a whole new insight into physics. It'll teach you physics with the calculus derivations. And then if you do that and prove your proficiency on that through either doing an AP Physics C exam or just like practicing a lot of their problems, then I think you're actually ready to go on to the proper like competitive physics materials. Like once you get to that level, you can actually appreciate the new content. Like from the really advanced books like Resnicality, Crane, Morin, and so on. A lot of the sites you'll find online will tell you to go to these books, and as these books are the Bible for understanding competition physics. However, one thing I remember I struggled with a lot was just going from like zero physics knowledge to like automatically like an a really advanced, rigorous understanding of physics. Like it's a pretty big jump, especially if you don't have the mathematical prerequisites required. Which is why I highly recommend, no matter where you come from, you got to make sure your math is really solid. Like you cannot understand any physics if you do not understand the math that follows behind it. Um, Honestly, as a 11th grader, I honestly thought my physics class was more mathematically intensive than my math class. Um, because that's just how math intensive physics is. So no matter what, no matter whether you go algebra based or calculus based, you got to learn algebra 2 like very solidly. You got to know trig very solidly. You should know sine, cos, tan, all those ratios like solid. No issue with that. And then if you want to learn physics at a more advanced level, learn calculus at the level of AB, BC. And then depending on where you start off, go through AP Physics 1. That will set you up for algebra based physics. Might not be good enough to qualify for F is equal to MA, but it will set you up well enough so that if you learn calculus and go into AP Physics C, you're definitely going to qualify. And then, yeah, as I said, yeah, just the AP stuff, like it can like get you in, but I would not recommend using that as your sole method of qualifying for the F is equal to MA exam, for qualifying through to USAPHO, because um, F is equal to MA, USAPHO, these are competitive physics exams, okay? The AP series, that's just standard physics. Competitive is always a step above standard physics. You're not going to get the problem solving by doing standard physics problems from either of the AP exams. Which is why, in order to supplement your knowledge on top of them, that is why we have those books, Resnick, Halliday, Crane, Morin, and Iridov. So once you get your physics knowledge and appreciation from just the AP Physics path, preferably AP Physics C, E&M, or Mechanics, then that is when you can actually start tackling the books like Resnick, Halliday, and doing problems from Iridov, and doing problems from Morin. And if you go through these books, like with Resnick Halliday, you do all the reading and you do like just like the most advanced problems from each section, because there are a lot of problems. It's impossible to do them all. But if you just do the most advanced problems from each section, you go through the entire book like that. That itself is probably good enough to get you on the international team. Similarly, if you pick another book, Iridov, right? Iridov really has really little context, which is why it's important to come into the book knowing the physics and mathematical prerequisites so you can follow along with the solutions. If you don't do that, you're gonna get really stuck. But if you go through each and every of the problems, as I said, you're good for the International Physics Olympiad. Similarly with Morin, right? Morin once again is it's a problem book. The context is really lame. Like I don't mean to hate on the books. The book is amazing, but if you want to go and try to understand it, you're gonna find that a lot more difficult than like if you go from scratch. Which is why you have to go with a good amount of prerequisite knowledge, and then follow along with the problems and their solutions. Doing stuff from either Resnick, Halliday, Crane, Morin, or Iridov, like these will really boost your problem solving ability, your thinking capacity for more advanced physics topics, right? But you cannot attack these books right away because if you don't have the physics and mathematical knowledge behind, you're not gonna be able to understand these books at all. So hopefully this has given you a good idea of how to prepare for the physics Olympiad. In case, like the short summary is, make sure your math is solid from like Paul's online notes or some other sort like that. Make sure your basic physics knowledge is solid from AP Physics 1. Make sure your calculus is solid if you want to do more advanced physics. And then basically just make sure the AP series is completely covered before you go onto the competition series. And then when you're on the competition track, depending on which book it is, Iridov and Morin, you should try to do all the problems. Or like as many as you can. But with Resnick, Halliday, Crane, just pick the more advanced problems, don't do the tedious ones. And then this itself should get you to where you want to be in the Physics Olympiad path. As I said before, right, to get really good at physics and physics competitions, you have to be dedicated, but at the same time, it's not as punishing as math is. So you can easily, if you're really motivated, you can easily make it from like just the starting pool of 6,000 to top 20 in only like 2 years. So hopefully this is giving you more insight into the Physics Olympiad and how I made the United States Physics Olympiad. And hopefully you can see this as a new potential topic or competition track you might be interested in pursuing. Thank you, and just tune in for our next video.